this video is all about exponential graphs. So I'm just going to walk you through some key things to know about graphing exponentials and what they're going to look like. The general form of an exponential function or an exponential equation is y equals ab to the x. So when I have this form, a is my initial value, also known as my y-intercept. B is what we call the growth factor. Now, I have two different sketches here that I'm going to do for you because there are two different types of exponential functions. There are exponential growth functions or exponential decay functions. So first I'm going to start with growth. So growth is when b is greater than 1. So for example, if I had something like y equals 2 to the x power. So when I have a growth function, it is going to be an increasing function that looks like this. Now, because a is my initial value or my y-intercept, and there's no number here for a, there's an imaginary 1, of course. So the y-intercept here is 0, 1. So this is really 1 times 2 to the x. Here's my a or my y-intercept. Now, if you notice, this graph will never touch the x-axis. The x-axis is what we call an asymptote. It's a line that the graph will approach but never touch. So it's the x-axis or the equation y equals 0. This is a general function or a parent function. There are no transformations. There's no shifts up and down. There's no vertical stretches. So this is what it looks like for growth. So the other option is decay. So when I have a decay graph, that means that my growth factor is a fraction between 0 and 1. So for example, it might be something like 1/2 to the x power. When this happens, my graph is decreasing, so it's going to look like this. My y-intercept is still the point 0, 1, because once again, I can always write this as 1 times 1/2 to the x. So there's my a or my y-intercept. Once again, I still have an asymptote on the x-axis. Don't mind my smartboard over here. So my asymptote is still in the same location. This is our decreasing function or our exponential decay. So just quickly want to talk to you about domain and range for each of these functions. So for domain, which is our x values, it's how far left and how far right we go. So this is all real numbers because my arrows are pointing all the way to the right and all the way to the left in both of these graphs. For the range, it's my y value, so it's bottom to top, or the lowest point to the highest point. So the lowest point that it goes is going to be the x-axis because there's that asymptote there and it'll never go below that. So it's going to be 0 all the way up to infinity because I have those arrows pointing towards the top. So as I said, these are your parent functions. I do want to take a quick look at two more examples with some shifts that happen so you can see what they look like. So I have y equals 7 times 3 to the x. First thing, I now have an initial value of 7. So that's going to be my y-intercept when I go to graph, 0, 7. Because I have a b value or a growth factor that's bigger than 1, it's going to be growth, which means it's going to be increasing. So if I were to just draw a quick sketch, you always have your calculators to take a look at. But just so you have a quick sketch of what it looks like, it's a growth function, so it's going up. My y-intercept is the point 0, 7. And your asymptote did not move. Here's my asymptote. That 7 in the front, in terms of transformations, is what we call a vertical stretch. It's causing my y values to be multiplied by 7. Let's take a look at one more. Y equals 1/3 to the x power plus 4. So I have a 1/3. This is my b value. So because b is between 0 and 1, it's going to be decay or decreasing. Remember that there's still an imaginary 1 in front. Okay, so that's my a value. But the special thing about this function is I have this plus 4 on the outside. So that means I have a vertical shift up 4 units. So I'm going to draw a quick sketch for you of what the original function would look like before we had a shift. So here's my function. Y equals 1/3 to the x. So what's going to happen here is this whole entire picture, the graph, the y-intercept, the asymptote, which is still there, which I didn't sketch in, but I'll show you now. That whole thing is going to move up 4 units. So that means that my y-intercept, which used to be at 0, 1, if I move it up 4, is now going to be at the point 0, 5. And I'm still going to have a decreasing function that looks like this. And my y-intercept is now 0, 5. But not only did that move, my asymptote moved as well. My asymptote used to be on the x-axis, which was the equation y equals 0. If I move up 4 units, my asymptote now moves up 4 units as well. So this is now y equals 4 as my asymptote. So this is the graph of y equals 1/3 to the x power plus 4. Remember, you can always check these things out on your calculator to compare them as well.